All right, hello there. So today we're going to start Unit 3, and it's going to be a very short unit, and it's even cut shorter because the county told us not to do as many of the topics in Unit 3. So here we go. All right, this first thing I want you to remember from Algebra 1. You solved systems of equations in Algebra 1. And so remember, it was usually like two equations paired together, something like that. And you had that little squiggly bracket on the side. And you had three ways of solving that system of equations. One way was graphing. The second way was substitution. And the third way was linear combinations, where you lined up the x's and the y's and then you added or subtracted the two equations together after changing them. So we are only going to solve them with graphing, and we're going to be using Desmos to do that, so it'll make it even easier. And but we're going to add some different kinds of graphs from there this time. So anyway, let's just review what you did in Algebra 1. So this first problem right here, to put these into the calculator or to graph them, you would normally like to solve them for y. So you have y plus 7 equals 2x. And so you went like this, take away 7, so you have y equals 2x minus 7. All right, so I have that one graphed here. Starts at -7 up 2 over 1. Okay, the second equation is 4y plus x equals 8. So you subtract x from both sides, and so you have 4y equals -x plus 8. Remember, with lines, we want y equals mx plus b. So we want the x in front of any numbers. All right, then divide everything by 4. So when you do that, you get -1/4 x plus 2. So that line is starting at 2 and going down 1 over 4, or up 1 and back 4. Okay, either way, you can see that they intersect right here, right? And so that's the intersection, is at 4, 1. And so basically, if you plug 4 into these problems, you get 1 for the y value for each of them, okay? So in Algebra 2, we're going to be doing more than just two lines. We are going to be doing stuff like this one right here, where it's like a parabola and a line, or maybe two parabolas. So notice that instead of just having one solution, like you do with lines, like that solution right there is 2, 3, you might have two solutions because they have two crossing places. Or, if the line was maybe like right here on the very end of it, or just brushed up against your parabola just a little bit, just in one spot, then you can have one solution. Or sometimes your line might not even touch the parabola at all. Maybe like the line's like, down here somewhere, and so it doesn't touch the parabola at all. Or you can also have two parabolas together, and same kind of things can happen. All right, so just remember that instead of only having one solution, you might have two. Okay, and you can have one or two, or you can also have none. We'll be doing lines and parabolas, and notice, like a parabola has x squared in it. You're going to notice that. All right, so the first thing you'll have to do, or be able to identify, is super simple. All right, now yeah, there's some circles on here, but it's the same idea. All right, so your solutions are where these things intersect. So if we go and pinpoint that place on all these graphs, I got a solution here and a solution there. I got a solution there, a solution there. One solution here. This third graph over here, there's no solutions because they don't touch at all. And on this last one, I have a solution here and a solution there. So all you have to really do is go through and write down the coordinate where they meet. So on this first graph, it's at -3, 0. And the other point where they meet up is 2, 5. So those are the solutions. You have to put the whole coordinate. On the circle and the line right here, let's see, 0, -3 looks like the first one. Now the second one I'm going to have to estimate. It looks like a little bit past 2, so maybe I'll say 2.3. And a little bit below 2 up above on the y-axis, so I'll say 2.3 comma, how about 1.8? So if you have to estimate, that's fine. All right, if you're in Desmos, then it'll tell you the exact answer where they cross, but if you're just estimating from a picture you're already given, then that's what you do. All right, this next one with the circle and the parabola touching in one spot, that's at 0, -2. And for here, for the solutions, you can just put no solution. Or if it's doing, you can say 0 with a slash through it, that also means no solution. All right, and down below here, Why don't you guys try that one and put it in the video answer for me. All right, so hopefully you put the point 1, -3, and the other point was 5, 5. So 2 solutions. All right, so you're gonna do this. We're gonna do some more of these with equations instead of just being given the graph. And mostly the biggest trouble you're gonna have is to solve for y. So technically, when you type these into Desmos, you don't have to solve for y, but I want you to do some math, and so I'm going to require you to solve for y. So let's go through, and you don't have this in your notes here, but we're going to practice this a little bit. All right, so solving for y. So if I have to solve for y, I would say to myself, okay, let's take away 2x, take away 2x, and when I write my equation, I'm like, okay, that's -2x plus 7. But that's also a lot of work. So another thing you could do, instead of writing that stuff down, is you can think to yourself this 2x has to go over to the other side. It's positive on the left, so when it goes to the left, positive on the left, so when it goes over to the right, it becomes a negative. It switches the signs when you go over the equal sign. So I'm going to have y equals, and then that 2x becomes a -2x, and the 7 just stays +7. So it's a little bit faster, and you're in Algebra 2 now, so you can do things a little bit faster. You don't have to follow all the old rules and whatnot. But anyway, I think that's a little faster to pop things across the equal sign. All right, this one. So I have a couple ways I could do this. I could move that 3x over, so I still have -y, and now it is -3x plus 4. And in the olden days in Algebra 1, we could say to ourselves, oh, this is a -1. I'm going to divide every single part by -1. All right, but instead of doing that, let's be a little bit faster about it. Why don't we say to ourselves, the y is negative, I want it to be positive, so make it a positive. And then just change everything else. The -3x becomes a +3x, the 4 becomes a -4, and then you're done. Now another thing you could have noticed is this. Instead of moving that 3x to the other side, you could have said to yourself, well, I'm going to move the y over here and the 4 over there. So that would be 3x, the 4 would become negative, and the -y would become a positive on the other side. And you see, I get the same thing. So however you like to think of it, whatever you like to do, whatever you tend to see, but try to do it the quicker way if you can. All right, let's look at this guy. So I'm going to pop that 5x to the other side, so I get 2y equals +5x minus 6, then divide every single part by 2. So these are just lines. Usually you want them in y equals mx plus b, 5 over 2x minus 3. All right. So you're always also going to have to do parabolas. Okay, this one has x squared right here, so this is going to be a parabola, not a line if you were to graph it. All right, so we want the y to be positive, so I'm going to leave this guy here. I'm just going to pop this -x² over, it becomes positive, and pop that guy over there. Now with parabolas, make sure we want to have ax² plus bx plus c. Okay, that's standard form. So write the x² first. It's going to be +x². Then comes the 4x, but it's a -4x now. And then the 1 just slides over. He's +1. Okay? All right, a few more. So with this one, if I brought this 4x over and this 3x² over, then I'd have to change this -y. So I think that's a lot of work. So why don't we just do this instead? Why don't I just put this y over here, it becomes positive, and put the 7 over there, and he becomes negative. So I get y equals, and then I have 3x² plus 4x, and then it'll be -7. And normally you would write it like this. And there you go. All right, so this one, I think I'm going to leave him here for now. I'm going to move these guys to the other side. So I have 2y equals, the 6x² becomes +6x². Then I'm going to put my plus 8x after that, and then the 10 becomes negative behind it. All right, then I should divide everything by 2. So I get y equals 3x² plus 4x minus 5. All right, let's take a look here. Now, in this problem, solving for y, this 8 here can go with the 9 eventually, so I'm going to take away 8 from him. So it's almost like solving, like we've done this before a little bit, like when we were solving by factoring and having to get everything together. So I have a -3y. It's still 5x² plus 6x, but now it's +1. All right, so I just have to divide everything by 3. Now you'll notice that this doesn't really divide by 3, so you have an option. You could divide the whole thing and just put a -3 and you'll be done. So you could write it like this: y equals 5x squared plus 6x plus 1 over -3. Or if you wanted to actually do it, you would say -5/3 x squared, and 6 divides by -3 makes -2x, and 1 divided by -3 doesn't go, so -1/3, just 1/3. So either of these two answers would be options for you, like however pretty you needed it to be. Okay? All right, and I think, is this the last one? Yes, it is. So this is the one I want you to write in the Edpuzzle. Solve for y. All right, so the quickest and easiest thing to do here would be to move the y to this side and bring the 4x squared to the front. So that 4x squared become -4x squared. I'd have -3x and plus 2, and the y would now be positive. So hopefully you wrote something like that, or maybe you switched it around and wrote -4x squared minus 3x plus 2 like that. Okie doke. All right, so let's go back to what we're really doing today, because we needed those skills to be able to do this. All right, so if you're given a picture, you can solve the system easily by picking the points of intersection. All right, but if you're not given a picture, you have to make your own, right? So I'm going to require you to solve, can't spell solve, oh well, for y first, okay? Because that's a skill you need. All right, so with letter A, so my new problem right here, both going to be y equals. All right, I'm going to move that x squared to the other side, so it becomes -x squared plus 4. All right, and then move this 4 to the other side, so it becomes x squared minus 4. All right, so we're going to go to Desmos and graph this, but I want you to see how you can kind of know what this is going to look like, right? Because -x squared plus 4, that's a parabola upside down, and it's 4 units up. So it's touching right here at 4, and it's upside down. All right, the second parabola has been moved, y equals x squared minus 4 has been moved down 4, so it's right there, and it's facing up. Now it turns out, I mean, you wouldn't necessarily know this, but it turns out that they cross right on the x-axis right there. So we're going to go see that. But just realize sometimes you can get an idea of what the graph looks like yourself. All right, so let's go look at these two things. I have them entered in Desmos. Turn them on, and there they are. They are crossing. If you click on the intersections right there, it'll pop up the point 2, 0, and there's -2, 0. So those are my solutions. So my solutions are 2, 0 and -2, 0. All right, for letter B, I think for letter B, I'm going to move this y over here and move that -2 back. So my answer is going to be y equals, then 4x, the -2 becomes plus 2. For this next one, I'm going to take away 2, so that'll be a -8 over there, and everything else is just going to move over. Like this -x squared moves over, the -x moves over, so I have y equals -x squared becomes positive x squared, -x becomes positive x, and remember the -6 minus 2 is -8. All right, so 4x plus 2, that's just going to be a line, and then I have a parabola x squared plus x minus 8. So let's take a look. There's 4x plus 2. All right, so this first one crosses off at -2 and -6, and sometimes you got to move over. Oh my goodness, this one is at 5 and 22. So 5, 22, whoopsie, and -2, -6. So 5, 22, and -2, -6. All right. So I'm going to jot that down. So 5, 22, and -2, -6. So I'll say, 5, 22 is like way up here, -2, -6, about there. And so I have my line as one of my problems going through there. And then the parabola, if I go back and take a look real quick at what it looked like just to get an idea, Let's see, it crossed at about -8 down there. All right, I think I got it in my mind now. All right, so it kind of went like this and came around and went up there. Okay, just a little sketch so you remember what you were looking for. All right, so remember you found out where they crossed right here. All right, so for letter C, you're going to solve for y. So I'm going to move this 2x to the other side so that I get 2y equals -2x minus 20. And then I'm going to divide everything by 2. So to start off, I have y equals -x minus 10. Then for the other one, all I have to do is pop the -2 over, pop the x squared over. So that's going to be y equals -x squared plus 2. All right, so -x squared plus 2, that's, you know, up here at 2, and then it's facing down. So I think I can get an idea of that. And then let's see, -10 is the other one. Y equals -1x minus 10. So when I graph that problem, it's going to be starting at like -10 and going down 1 over 1. So it's going to be going across here. So we'll see what kind of estimate this gave me. So I think about there and there, wherever that is. Okay, so let's take a look. All right, oops. Okay, so not too shabby. There's that one. That one is, that point right there is -3, -7. And then I have 4 and -14. So -3, -7, and 4, -14. So -3, -7, and 4 and -14. Okay, so those are those 2 points where they intersect. And you don't have to know what the graph looks like yourself. You can always graph it in Desmos, but you know, you should have an idea just because you do know how to graph things. All right, so your job is to do these problems on this page. You're going to look at what I, you know, just like I did, solve these for y. Put your answers right here when you solve them for y. I got it set up for you. You're going to write your solutions. Might be 1 or 2 or none. And then you got number 2 to do also, but you can kind of see that there are your equations. Basically, instead of t's, you can put in x's in Desmos, and h can be y, and so then you can get them typed in there. Now, these are pretty big numbers in these, so you might have to kind of zoom out a little bit to see the solutions. Okay? All right, and that is it.